Okay, so now we're going to look at an example where f of a isn't in the table. So here I'm just saying, what if we want to estimate the derivative at our point x equals a, but we don't even know what f of a even is? Like x equals a is just not found in the table. So what we're going to do is pick two x values closest to x equals a, and then just consider the average rate of change between those values. All right, so here you can see this example where I want to estimate the derivative at 2, and 2 is nowhere to be found in the table. So what I'm going to do is find the two closest x values to 2. And so here, I hope you guys agree that it would be 0 and 5 in this table. So I'm going to just pick to consider the average rate of change between x equals 0 and x equals 5. So I'm going to say that the derivative at 2 is approximately f of 5 minus f of 0 over 5 minus 0. And so this is negative 20 minus 30 over 5, which is negative 50 over 5, which is negative 10. Okay. So now, in this one, though, in this practice problem here, f prime of 0 is in the table. But what is different about this example versus practice 1 is that here, when you look at 0, we have that negative 5 is close to 0, and so is 2. But which one is the closest? Right, so here, I hope you would say that 2 is closer to 0 than as opposed to negative 5, right? The distance between negative 5 and 0 is 5. However, the distance between 0 and 2 is 2. So we should be picking these two values here to approximate the derivative at 0. All right, so here, this would be f of 2 minus f of 0 over 2 minus 0. And so this would give us negative 20 minus 30 over 2, which is negative 50 over 2, which is negative 25. Okay, so you want to make sure that you are paying attention to that part. Which x value is the closest to x equals a in the table? So in this case, it would be 2. All right, so you're just going to consider the average rate of change between 0 and 2. Whereas in practice 1, we saw that negative 5 and 5, they both had the same distance in between 0. So that's why I considered both the left-hand and right-hand approximations. I found the average rate of change in between negative 5 and 0 and 0 and 5, and then took the average of those two to get the best approximation.